All right, I was about to run out of time, but I want to hit this before I flip pages. So right here, if you look, this jumps by 2 and this jumps by 4. You're going to still end up with the slope of change in y over the change in x, which is your y's over your x's, still a slope of. Use patterns and relationships. A lot of people mess up because they forget to keep the y on top. Always have your y on top. All right, let's go ahead and flip this page. All right, for the following two functions, identify the slope, y-intercept, and x-intercept, and create a table and graph. Let's get it. So, what is this? 0 is always a nice one to have in there. Let's go, what? -1, -2, +1, +2. So we know slope-intercept form, y equals mx plus b. So our slope is 2, because your slope is always with your x. My y-intercept is -2. Ooh, my x-intercept. My x-intercept is when y equals 0. So when your results equal 0, what was your x? So I'm going to add 2 to both sides. And then I'm going to divide both sides by 2. Get it? So my x-intercept is going to be 1. Alright, so let's do this. So this is 2 times -2 minus 2. Oh, let's do this. Alright, so my previous calculator was emotional. Let's see if this one does it. So this is going to be 2 times -2 minus 2, which is -6. Let's see if you act right. If you press your arrow button up, why is this doing this? On other calculators, you can press the arrow key up and just retype over it. Yes, let's go. So it's worth it. If your calculator doesn't do this, let me know and we'll get to it. All right, so this is going to be 2 times -1 minus 2, which is -4, which matches, right? So we have a slope of 2. So every time these are off by 1, those are going to be off by 2. So if I go up 2 again, this is going to be, so just in case, I'm going to go hit enter and it retypes what you had. Plug 0 in instead. Let's go. So as long as these go up by 1, those will go up by 2. So 0 and 2. Just for fun, I want to make sure I'm getting this right. Because sometimes I move too fast. So busy trying to make sure everything and slow down and get it right. Let's go. Oh, before I start circling stuff, let's graph this. So -2, -6, -2, -6, -1, -4, 0, -2. Y-intercept is 1. Yeah, I got it on there. When you draw a line, I can't say it enough, it's going to be problems and consequences. Draw it all the way through. And using what we know, let's go back and look at this. Our y-intercept is -2, and our slope is +2. So up 2 over 1, up 2 over 1, up 2 over 1. So Sometimes you get it perfectly pretty. Sometimes you don't. Respect. That's what it looks like. Ooh, is this the one we did before? 4x minus 2? I love it when I've done something already. Boom, 4x minus 2. So my x-intercept is, okay. Yeah, let's do this. So I'm gonna go -1/2, 0, +1/2, 1 and 2. Let's get it. My slope, mx plus b. Slope is m, so this is 4. My y-intercept is the back number. What am I doing? I'm dangerous. So that's -2. My y-intercept, already figured it out, y'all. That's what I love about paying attention, is 1/2. So let's use this. So this is going to be 4 times -1/2 minus 2. Go back up. Tell you what, let's make that +1/2. +1/2, 0. Go back up. When I plug in 1, boom. Let's go. Which makes sense because these go up by 1, this goes up by 4. So that's how you see your slope in something. Oh, we have to go back and put 0. So this is -2. Get it? Which matches my y-intercept. Oh, didn't think this through. -1/2, -4. Boom. 0, -2. +1, +2. This thing is steep. +2, +6. My solid numbers and try to line this up as best as possible. See, that's the tricky thing about graphing though, is your line has to be exactly where it needs to be to find numbers that you didn't type in. So this goes up by 1/2, that goes up by 2. So your slope still works. So the change in y is always on top. The change in x is always on bottom. So what do you notice about the slopes between function 1 and function 2? Wow, yeah. Function 2 is steeper than function 1. Also, function 2, slope equals 4. Function 1, slope equals 2. So this is twice as steep as that. Yeah. How does this affect the y-intercept? Oh, the y-intercept don't change. So the y-intercept does not change. But my x-intercept is half as much. Ooh, diabolical. X-intercept is half. So let's be clear. So this is function 2's x-intercept is half function 1's x-intercept. You have to be very clear. Because if I flip that, function 1's intercept is twice as big as function x. So order matters when you're describing something. Get it. All right. So we'll pick up on this one in the next video.